Welcome to The Hardware Stack, December 30, 2025. Today, we cover AMD's dual-cache Ryzen 9 950X3D2 D7VK11 with Direct 3D 6 support, TSMC's second-emer production, and penny-sized autonomous robots. AMD's Ryzen 9 9950X3D2 has appeared in benchmark databases for the first time, featuring a dual cache design with 1.2 megabytes of total L3 cache stacked across both chiplets. This configuration doubles the standard 96 megabytes found in previous X3D models, which typically feature 32 megabytes of standard L3 cache plus 64 megabytes of 3D V cache. The CPU maintains a 16-core, 32-thread layout with a boost clock of 5.6 GHz. Geekbench reports a single-core score of 3,456 and a multi-core score of 21,062, with the single-core results being the highest on the database. Passmark shows a multi-core score of 71,585 and a single-core score of 4,706. The TDP is listed as 170 watts, contradicting earlier 200-watt rumors. These benchmarks confirm the chip's gaming-focused design and cache optimization. D7VK version 1.1 has been released with experimental Direct 3D 6 support and a new front-end, enabling near-native performance for vintage Direct 3D 7 games on modern hardware through a Vulkan translation layer. The translation layer converts Direct 3D 7 calls to Direct 3D 7 calls to Direct 3D 9 under Proton's DXVK, avoiding the performance penalties of full emulators like Wine D3D, which run several times slower. Specific fixes include a workaround for Sacrifice's unsupported depth buffer format, strided primitive rendering for Sacred, and mid-mat swapping fixes for Gothic, Gothic 2, and Star Trek DS9, The Fallen. This update improves compatibility for over a dozen older titles, including Conquest, Frontier Wars, and Tomb Raider Chronicles, without requiring emulation overhead. TSMC has begun volume production of its N2 SU-MX class fabrication process in the fourth quarter of 2025, as previously announced, without a formal press release. The N2 process delivers a 10% to 15% performance gain at the same power, a 25% to 30% reduction in power consumption at the same performance, and a 15% increase in transistor density compared to N3E for mixed designs. This marks TSMC's first adoption of gate, all-around GAA nanosheet transistors, where the gate fully surrounds the channel formed by stacked horizontal nanosheets, improving electrostatic control and reducing leakage. The process also incorporates super high-performance metal insulator, metal SHPMIM capacitors, which offer more than twice the capacitance density of prior designs and reduce sheet resistance by 50%. Researchers from the University of Pennsylvania and the University of Michigan have developed fully programmable autonomous robots measuring 200 by 300 by 50 micrometers, smaller than a grain of salt. Each robot costs 1 penny to manufacture and uses ion propulsion, generating an electric field to nudge ions in surrounding solution for movement without moving parts. Powered by solar cells making up most of the robot's mass, they generate 75 nanowatts of power. Programming occurs via light pulses, while data retrieval uses a waggle dance motion. These robots, designed for medical applications like temperature sensing and microscale manufacturing, can operate autonomously for months due to their efficient solar power system. Penn Engineering handled physical structure, while Michigan provided the processor, memory, and sensors, leveraging their record for the world's smallest computer. Thanks for listening to The Hardware Stack. Next week, we'll dive into the latest in AI hardware innovations. Stay tuned for more insights.